Cool. Thank you. Can you guys hear me? Seems like I'm louder than usual. Cool. So I was struggling actually yesterday, or talking to SW over there, and trying to figure out what would be a good approach for this audience, right? So I assume many of you, if not all of you, are familiar with SMB and SMB3, right? And I'm prepared to do a little quiz to kind of start, right? So what is the dialect of SMB in Windows Server 2012 R2? Huh? 302. Good. Second question. When you're using RSS-enabled interfaces in both ends, how many connections per NIC will multi-channel do? A lot is correct, but not quite what I was hoping for. Any takers? 4? 1 per core? The answer is 4, right? 4 per RSS cable interface by default. There's actually a setting to go do that, right? When configuring Hyper-V over SMB, what permissions are required on a share?
For the spatial.
Full permissions for the computer accounts that are coming in, right? Okay, so just trying to kind of paint the picture here. Let me go back to the beginning and try to paint something of a scenario. So first of all, when you say storage and Microsoft, and there's a ton of different things that we do in the area of storage. And before we even start focusing on what we're doing here, there are a few things that you will notice. So we do Azure storage, right? We do hybrid cloud with the Store Simple product that I hope you heard of. We acquired the company, and it's delivering a solution where you have some storage on-prem and some that goes to the cloud. And then we have here on the left side the private cloud solution, which is not Azure, but on-prem. And in the on-prem solutions, there are two styles that we talk about. One is the private cloud with partner storage, meaning that you bought storage from one of our storage vendors, and you're hooking that up to Hyper-V, right? That's one way to do it. There's two typical ways to do it. One is through block, the other through file. And there are implementations all over the place, right? And then we have the solution using the Microsoft, what we call the software-defined storage stack, right? Which is to say that your storage box is actually running Windows Server using solutions like, for instance, storage spaces, the Microsoft native deduplication, all those things, right? So I'd like to describe that because some people see all these different things that we're doing, and it's hard to kind of figure out the details of each one. So our focus is going to be, for this talk, in this area here, on the file side of the private cloud solution and on the Microsoft SDS solution. Typically, for the scenario we're talking about here, you're building a private cloud. So you're hosting a whole bunch of VMs that are running all kinds of workloads, maybe SQL, maybe web servers, maybe even other file servers. And in that scenario, you have a cluster of what we call compute machines, right? So these compute machines are machines that are running Hyper-V. The other set of machines that you have here are your storage machines. So I'm depicting here the Microsoft solution, where you have a scale-out file server running Windows Server 2012 R2, running storage spaces, a whole bunch of disks in the back, typically shared SAS JBODs, and that is how we paint that picture. So if you come to us and say, hey, Jose, I have no idea what to do for my private cloud. What should I do? So that's typically how I would walk in the room and describe it. There are a few things here, right? So first of all, when we're talking private cloud, we're usually talking about VMs, right? So everything runs inside VMs. There are only two things that are not running inside VMs. One is the compute. So Hyper-V itself is not running inside the VM, because that would be kind of recursive. And the storage is typically not running inside the VM. Although I've seen solutions out there from partners where even the storage controller actually is inside the VM. But typically, when people think about it, these two are bare metal. The other thing we're saying is disaggregation. Disaggregation is important. Why? In most cases, people want to scale. When we talk private cloud, people think, oh, we're going to have to host hundreds, maybe thousands of virtual machines. And that works best when you separate your compute from your storage. So in this solution, when we paint this, there's a cluster that is your storage cluster. That's this bottom half here. And there is a cluster that is your compute cluster. And we keep them separate, right? Jose, could we do it the other way around? Could we combine them and do aggregated? Yes, you could. The technologies allow for it. Problem is, scale of the compute and the storage don't typically happen proportional to each other. So it's very common that you end up with too much storage, that you don't have to do anything to do with it, or you don't have enough storage for your compute, then you end up with too much idle CPU. So by separating two layers makes it easy for you to size it properly and have the best solution there. Now diving into the piece that we want to talk about really here, which is you decided that you're going to do file storage and you're going to do this on the Microsoft platform. How would you do it, and why is that important, right? So to get into the heart of the private cloud solution that we were describing here. So we believe that file storage is more flexible than block storage, right? And that the world is actually driving to it. It's not only a Microsoft thing. We look around and we see more and more people switching from traditional block storage to file storage. Why do they do that? There are certain flexibilities that you get when you go with file, right? One of these things, I'll give you a practical example in the Microsoft platform. If you ever try to do Hyper-V and you use block storage, which you can, right? What happens is you have to expose the LUN to a cluster. So I have some storage that's shared. I expose that to a cluster. I have to do it consistently to every node of the cluster, and I can never expose that LUN to more than one cluster at a time. Why is that? Oh, well, because if you expose the same LUN to multiple clusters at the same time, they're going to disagree with each other. They're going to try to arbitrate that LUN, and what you end up is one cluster fighting the other for access to that LUN. Now, switch to a file-based solution. So you can have two Hyper-V clusters accessing the same file storage, and they can live happily with each other, right? Because they are not going to fight for those resources. It operates a little different. That's one example. That leads to much simpler migrations. So if you think about it, if I need to migrate storage from one cluster to another cluster, since they both can see it, I can actually do a live migration from one compute cluster to the other compute cluster, right? And that is not hard. In fact, if you notice, one of the things that we can do since Windows Server 2012 is we can migrate. You get a laptop running Hyper-V. Say you put Windows 8 or 8.1, and you have another laptop with Windows 8, 8.1. I can actually migrate from one to the other, and they call this shared nothing. Live migration, have you heard of that term? It's basically, there's no shared storage, it's just Hyper-V running in this machine, Hyper-V running in this machine, and I can live migrate between the two. Most people believe that's actually shared nothing, live migration. It isn't. So how do we do this? It's very simple. Hyper-V, when you do these shared nothing things, it actually shares, creates a share on the machine where you want to migrate to, and then it actually moves the data to that share using the SMB protocol, and then it moves over the VM. So in the end, these flexibilities in creating shares and just moving files around gives you that. And there's a ton of examples in the area of snapshotting, in the area of Hyper-V replica, and all these things that they require the use of VHDX files, and they operate really well outside of this confine of having a block device that is the way to go. So that's the explanation. We are all looking for these very, very flexible solutions out there. So a few things here. So you can read the highlights here. We see how we are switching to this mode where everything in our network is starting to be shared, right? So we're more and more pointing people to say, no, you should have a single network. Some people are still with the notion that you have a data network in the back, like a east-west network, if you will, between your compute and your storage. In the front end, like a north-south that goes from your compute to the outside. But there are people that are actually going to the place where you actually don't have that distinction, that you actually have a converged network environment. And people are driving towards that goal and creating these solutions. So that is generally what we're seeing, and that rhymes with all the stuff that we're talking about here. That plays really well with the notion of having file-based storage using the SMB protocol. Now, the SMB protocol, specifically for server applications, it is something that took some work. Because if you remember how things were just a few years back, so think Windows Server 2008 R2, we had the version 2.1 of the SMB protocol, and we had some real trouble hosting these server applications. Why was that? Well, because if you're hosting simple Office documents, right, or text, it's very simple to, you're trying to save a Word document, there's a little glitch in the network, you just save again, and it's okay, right? It's fine. You can take a little failure, a little glitch. But when you're talking about running private clouds over this, you're talking about storing your running VHDX files on a share, you want to make sure that there are no glitches, right? You don't want to actually have to go to your application developer and say, hey, by the way, now at any point your storage can fail, and then you have to take recovery action on your end to make that go back to normal. So it was a primary goal to say, we need to make sure that you can have this file protocol, but it absolutely feels as a solution that is directly connected to you, that never fails. Even if you move between machines on your storage side, even if you have a failure on a NIC, which is, it happens, right? So we had to put inside SMB a whole bunch of things, starting with transparent failover, which is this ability to move between machines or to have a machine fail on you and you just transition that automatically, or to have something like SMB multi-channel, which is the ability to have multiple paths between your compute side and your storage side, and not only you actually survive the failure of a network path, but when both paths are active, you can get twice the bandwidth without any teaming, without any multiple session configuration. It just happens, right? So those are the things that we introduced in Windows Server 2012 in SMB 3.0 to make that whole thing possible. And other things are less obvious, like encryption is something everyone is talking about these days, more now than when we started with this whole move to SMB 3. Backups are an important scenario, and performance is also a key piece, right? So one of the things that we knew back then is that SMB2, SMB1 were not the best performance that you could get out of that wire, right? And even if you restrict yourself to TCP/IP, even if we got the best possible performance, there was still some challenges with using TCP/IP in terms of how much CPU it uses, right? I'm not sure if you ever tried with these, have you played with these fancy 40 gig NICs that we have these days? So if you try to do 40 gig between two machines using TCP/IP, and you start sending back and forth, say, 4K data packets, right? Just start sending back and forth, or 1 meg, or any size. Just start exchanging data between these machines. And just watch what happens to your CPU. 40 gigabits per second is a lot of bandwidth. It's a lot of data, right? And what's going to happen is you're going to use a whole lot of your CPU just to pack data on the wire. It can be quite a lot, depending on what kind of CPU you have. And if you actually end up using two 40 gig ports, right? The amount of effort that you have to put into just to transfer that data is going to be a lot. And there will be not so much CPU left to actually run your virtual machines. That's a big problem, right? That is the notion of SMB Direct, right? So the idea that we can now use these NICs that can do the task of offloading the transfers. You can do very large 1 meg, 8 meg transfers between machines without the CPU having to do any packing or unpacking. It just picks up from memory in this place, drops on the other side, right? That's kind of the big picture. And the whole notion here is we don't do this stuff because we like storage. We might argue that, but that doesn't fly too much with our bosses, right? So we actually do this stuff to run these apps. So to run SQL, to run web servers, to run your desktops inside these virtual machines. Right? And the whole notion here is that this infrastructure exists to give you nice storage that's not expensive, that's fault tolerant, and has all these attributes that's secure and all we talked about. Now, these are the main capabilities. We talk about most of them. So I grouped them here by capability. So in the availability area, we have transparent failover, which is effectively persistent handles, right? So what we call CA, right? Continuous availability. And that is the core piece of what we're talking about here. Without that, I don't think any person with a sane mind would put any SQL database or any Hyper-V workload of any kind on your solution, right? So you must, that's like number one. We also have something called Witness. How many of you are familiar with Witness? So Witness, is Witness required or not? That's one of those tricky questions, right? Is Witness a required piece to do CA? Can you do CA without Witness? And what's the problem that Witness tries to fix then?
Slow failovers.
Problem is called timeouts, right? It's hard to figure out when something failed, when the only mechanism for detecting failure is timing out. And so that's not good, because you spend some precious seconds, some 20 seconds just waiting for something to fail before you can take to the next step saying, oh, that failed, I need to take some action, right? So what Witness does is it lives on the other side, lives on the server side, and constantly monitors the environment. And when something fails, it can actually tell the client ahead of time, oh, you just sent something to this guy is dead. It will never come back to you. You might as well just ignore it and do whatever recovery action you have to do. It might actually hint at someone else that is alive and ready to take your connection, right? So that's as important as, but it's not mandatory because you can actually wait for the timeout and you can still do the reconnection. It's actually kind of okay. It's better with Witness, right? Now, where in the SMB protocol do we describe the Witness? That's a trick question, right? Because the Witness protocol is not part of SMB. It's actually a separate protocol. It's actually RPC-based, right? So it's another document that you have to go look into it. Totally optional, but highly recommended, right? I spent enough on multi-channel already. So multi-channel is that ability to do multiple NICs at the same time for two reasons: for fault tolerance and also for aggregated throughput, right? And there's a little trick in multi-channel as well, which is a nasty little thing that happens. And when you're trying to do, say, remember that 40 gig NIC that we try to do? If we don't use more than one TCP connection, just do one TCP connection, what happens in Windows is that one connection is going to use one of the cores. And we will try to do the whole work of flowing data over that 40 gigabit throughput using a single core. Guess what happens? That core saturates and you can't hit 40 gigabits per second, ever, right? Because the cores are not getting faster, you just get more of them, right? So in general, that helps with all those. Speaking of that, I'm kind of jumping down to performance. So we talked about multi-channel for performance, and that's one of the pieces. SMB Direct, some of these capabilities like leasing and branch cache, which is effectively is kind of keeping some of the data on the client, avoiding trips to the server. Not so important in the application server environment specifically. And scale out. Scale out's a fun one. Anyone here already played with scale out, implemented a scale out solution? So scale out comes down to breaking that rule that when you go find a share, there is one place where you find that share, one machine. When we introduced scale out, we kind of broke that rule. Now you can actually have a set of machines that offer that share. And any of those machines can be used to go and serve out that share. Obviously, in order to implement that, those machines, they have to all go back to the same shared storage in the back. And it doesn't really matter how you get there, as long as every node that you expose effectively can offer that share and respects all the rules of sharing files. For us in the Windows side, we implement that with cluster shared volume backend. So we have this notion in Microsoft failover clustering that we can create a volume that gets exposed in multiple machines at the same time in the cluster. So we basically put a share on that, and that's our version of scale out. And it basically creates that clustered volume that all the nodes can access, and I can actually share the same data across. Before we had cluster shared volumes, we had this thing in cluster that a volume could only be online on one node at a time. So if you had 4 nodes in a cluster, the old days before CSV, that volume could only be online on one of the 4 nodes. So only one of the nodes could serve data off of that volume. Starting with, when was that introduced? 2008, R2. We created this notion that you could have the same volume seemingly mounted on all nodes of the cluster. And all nodes could get in. There's actually some trickery going in the back, as usual. Right? One of the nodes actually owns the volume and does the metadata operations on that volume, but we don't have to go into detail here. But that's basically what we get out of scale out. You need to have your solution for backup. So VSS gives us the ability to do snapshots on file shares in a way that applications already know how to do, because this has been around for a while, the VSS portion of it. We introduced encryption, I mentioned that, and we already had signing. And for management, we have 2 pieces. You can, when using Windows, you can use PowerShell, which flies over SIM, which uses WSMan, if you're familiar with all the protocol soup that goes underneath, right? But typically, if you're a third-party NAS solution not running the Microsoft stack, there's something called SMIS, which is a protocol for storage management. And in that, we have file abstracts in this. There's a set of basic infrastructure for managing file share. So that's how you can do things that we cannot do in line with the protocol. So you can definitely access a share, and you can create folders inside the share. You can do all these things. But how can you query what shares exist, right? So inside the SMB protocol, there's no way that I can open a connection to you and say, hey, give me a list of shares that you have. So we use SMIS file to do these kinds of things, or for instance, to set permissions on the share, right? So these things usually happen out of band of the SMB protocol. And I know there are some very old protocols that we use to do those things, and you shouldn't even think about them, right? The 3-letter acronyms, they're not there anymore. Actually, they are, but think like they're not, right? That's basically how you should think. Like SMB1, right? We should talk about SMB1. And then 302 was the latest one. That was 1 year after, right? That's the Server 2012 R2 was the release that matched this. We did a few interesting things. One is the asymmetric clusters and the notion of rebalancing. So when you talk about scale out, yes? Question?
So I had always made a simplifying assumption that PowerShell was a superset of these primitive SMI and weird, that PowerShell could do everything.
Yes.
And that the other stuff was just sort of compatibility, integration stuff. So the most common example a server guy cares about lists the shares.
Mm-hmm.
We loved it over RPC because we all knew how to do it. We hate SMI because you have to implement new daemons and new weirdness. What does it look like over PowerShell?
Well, the question is, can PowerShell do everything that SMIs can? Why would I do one over the other?
You can do SMI because you've got a tool that depends on it's got to work with some other weird server.
Yes.
But if PowerShell does everything functionally, it's useful to know what PowerShell uses on the wire.
Yeah, so PowerShell on the wire uses something called WSMan. So there's a way for you to go and implement, but honestly, what we guide people to go do is to actually implement SMIS, because this is the tooling that we are building on, which is the virtual machine manager and all the tools that do block and file, because typically behind that file share, there's block storage as well, which you might want to actually go and manage the pools, manage the disks, the LUNs behind those and all that. So that has a full set of capabilities in that area. If you want to use PowerShell, you can use PowerShell. We actually have all the classes that we use and all that good stuff. But typically we recommend people use SMIS file. You got a question?
Yeah, I mean, the last time I looked, the SMB command list for PowerShell weren't actually remoteable, but relied on the remote session capability of PowerShell itself.
Mm-hmm.
Is it possible to get, they're all WSMan, I guess you can do the shared enumeration using WSMan for databases as well. How do you trigger those, or do you just have to go find a spec? Because PowerShell itself didn't support in 2012, didn't support getting remote shares.
Yeah, we remote those through SIM. I'm not sure if there's any limitations. Yeah, it's WMI v2 on our end, which flies on top of WSMan. I'm not.
Yeah, so that's fine. So the answer is go find the spec for how to do it.
Yeah, we're not doing anything fancy in the file server side of the story. We have a whole set, so we have that for networking, for storage, like block storage, for shares, for pretty much everything, Active Directory. All these things are flying these days on top of WMI. And our PowerShell is actually a very thin layer that basically just wires PowerShell to the WMI that we have underneath. So do you have anything to add, SW?
Yeah, just for Steve's question on why do SMIS. If you heard Sean Bopaz's presentation earlier, if you missed it, thank you. The reason to do SMIS, if you heard Sean Bopaz's presentation earlier, he sort of hinted at or stated that there will be a forthcoming requirement if you want your storage certified under the Windows logo, Windows Server Catalog, something like that, then you'll have to pass the SNIA conformance test program for SMIS.
That's a good point.
And so that's one reason to do it if you care about selling your storage into those requirements where a customer may require that your storage is in the catalog.
Okay. And one of the things here in regards to rebalancing, right, we had an issue that when you had scale out in the 3.0 version of it, we could actually land on any node of the cluster, and we didn't do anything automatic to kind of share the load across the machines. So if you had 4 nodes in a cluster, it could very well be that you end up with a whole bunch of shares, a whole bunch of connections landing in one node, and the other nodes were not busy at all. And that was very common as you come in and you do, for instance, a restart of a node because you did a patch. You can, at any moment, patch and reboot, and because of transparent failover, the connections flow to another server, but there's nothing that would bring those connections back. So effectively, what we told people back in SMB 3 in 2012 was say, run this PowerShell script that hooks into the witness protocol, and it will tell people where to go, and you could spread out the load again, right? But that was kind of a manual thing. And in 2012 R2, we made a point of creating this way to automate these connections and actually connect per share. So that if you have a 4-node cluster, you can have, say, 4 shares. The 4 shares can get spread across the nodes, and we put in some plumbing that automatically spreads the volumes around and automatically creates these affinity between the share and the volume, and then the clients hit the right node every time. So if you actually have a share here in this node 3, and you have to patch that node, then that node is evacuated, rebooted. When it comes back, it gets that volume back, and then the clients flock back to it. And you don't have to do anything about it. You just use the latest release, right? In order to make that happen, we actually have to make the connection to the witness to be based not on the name of the server, but actually on the name of the share, so that we could redirect you separately to different places based on the share, not only based on the scale-out name. There was a question here somewhere.
Are you measuring I/O per share?
No, we're not rebalancing based on the I/O. So the question is, are we rebalancing based on the amount of traffic coming in? No, we took a simple approach to say we will do it per volume, and we'll spread the volumes around. And if you put a share per volume and you have volumes of fairly similar size, you will get that balancing behavior to work for you. And that's actually a harder problem than it looks at first. So we kind of took an easy approach. And we also had this notion that we can rebalance you per share to kind of facilitate that. And in general, we have more volumes than we have nodes, right? In most setups that we work on. So that worked out okay. And we thought about it, something about balancing based on load. Those are just too complex, right? And we really, basically, this is just using the witness protocol to give hints to clients to move to the right place. We really didn't do anything hard-coded to say, oh, you must come here. If you come to the wrong node, we'll boot you out. No, that's not it. It's as you come into the node, if it's not the right node, you get the hint from the witness protocol. And if your client's behaving properly, it will move. And we validate that behavior. Works fine. We also did some work on SMB Direct to improve performance. So that's the RDMA portion of it. There was some clever tricks that Greg was cooking there to kind of avoid a few of the steps that we needed during RDMA. We do we register memory, then we do a transfer. Then once we get confirmation that transfer happened, we go and deregister the memory. So we've effectively found a way that we could just say, do the transfer. When you're done, just deregister automatically. I don't need to go there and give you specific instructions to deregister, and then listen for the confirmation of that. So we avoided a few steps there, and that paid off big time. And we're from a protocol perspective, that was the main change. And then guest clusters, which, again, guest clusters is not really a part of the SMB protocol. It does, however, use SMB as a transport. So it's kind of related. And if you have an SMB3 implementation, soon enough, someone will come to you and say, hey, I was trying to do that shared VHDX thing, got an error message saying that you don't support it. So there is actually something that was a presentation yesterday, something there that you need to go do, and it's a long conversation, but just keep in mind that this is important. And interestingly enough, that is one of the things we're hearing a lot from customers. That really simplifies how guest clusters are configured, and that's a really important feature. We've seen lots of folks asking questions about this, and customers that are already implementing it, and this was just like 6 months ago, practically, that we shipped that thing. So, and maybe a little more, maybe 8 months. But it's being very well received by customers because it simplifies things that you otherwise would have to use iSCSI to the guest or virtual fiber channel, which are usually very hard to configure. Yeah.
So when I think about that RSVD talk
Yes.
What we heard last year.
RSVG is the remote shared virtual disk protocol that is behind the shared VHDX.
And when we heard the similar talks last year, the impression I got was that it had performance and functional advantages for dealing with this type of disk.
Yes.
Whether or not you ran clusters.
Well, the shared VHDX question is, what are the advantages, right? So the notion of shared VHDX, or the remote shared virtual disk protocol, is that, first of all, it simplifies the configuration. It keeps that isolation in your virtual layers, right? So today, if you want to do guest clusters using iSCSI, you actually have to tell your guest what is the IP address of your iSCSI target inside your data center, right? You have to open that pathway. Same thing for virtual fiber channel. You have to actually give that virtual machine a worldwide name and a path straight to your fiber channel SAN. And some people don't like doing that. And you can protect it. You can do a whole bunch of things to kind of protect. But wouldn't it be nice if they could not really even see if it's iSCSI or fiber channel in the back? It just shows as a virtual disk that just happens to have the right semantics for clustering, that can do persistent reservation, can show up in multiple places at once. So that's what we're doing. We're creating that abstraction layer in shared VHDX so that you can create, in the end, the guest clusters. And it turns out that from a performance perspective, we were a little concerned at first, but I'm not sure if it's just because of the way we're doing it, but if you look at it, we actually can, with shared VHDX, leverage RDMA, the way this thing is architected. And when you do iSCSI to the guest or virtual fiber channel, there's a longer path. So we kind of got a good design going that, in general, we don't see performance impact on the path. In fact, if anything, we see some improvement in some scenarios. So it's all good from a performance perspective as well. That's a good question. In the non-cluster, if you're not doing guest clusters, is there a good reason to do shared VHDX? Right up front, I'll say no, because you can just expose to the same path. The difference really here, if you think about it long enough, is where your VHD parsing happened, right? And you're doing traditional Hyper-V over SMB, the VHD parsing happens on the compute side. When you're doing shared VHDX, the VHD parsing happens on the store side. We can probably argue over beers whether one is better than the other, but nothing earth-shattering. You can try it. There's nothing stopping you from doing it other than the fact that you can't do this with anything other than SCSI disks. So you can't do that for your Generation 1 VM boot disk because that has to be IDE. But if you're Generation 2, or there's a whole lot of things, we generally don't think of it as being used for, if you're doing shared VHD, is that you're doing guest clustering, you're actively trying to share them. Can you use the semantics without sharing? Yes, I guess. Not something we design it for. But you know, it happens a lot. Sometimes we design something for one thing and people use it for something else, and sometimes it's one of the greatest inventions on earth. So let me know. If you see a big advantage. We didn't design it for it. But. All right, so one of the important things here is that we want you to move to SMB3. If it wasn't obvious up to this point, right? We are really interested in having you get off the 22110. We celebrated the end of XP, and we're looking forward, counting down to the support, the extended support expiring for Windows Server 2003, which will be the end of SMB1 from our perspective, right? We're going to stop shipping any OS that supports only SMB1, right? At that point, there's no good excuse anymore. But still, there's a whole lot of folks out there that run other OSs that might not support SMB 2 or 3, right? So Apple made the move, right? So they're now SMB 2. And I've heard from everyone saying that, we got at least 2, right? And aside from some crazy printers out there, we're looking forward to kind of exterminating that older dialect. It's better for us all, believe me. But anyway, The point here is 3 and 302 are okay. They can negotiate, as you probably know already. And I was actually trying to see how I would kind of end this talk. And one of the things that most of the conversation we had around this comes down to, okay, so you have this whole list of things that we can do, right? So now SMB3 has all these capabilities, right? So these things that, oh, you can do SMB3 and it might mean nothing because you didn't implement any of the optional capabilities in the protocol. And I've seen it happen, right? Some people say, can you do SMB3? Yes. Can you do persistent handles? Oh, unfortunately, I can't. Then that's not really SMB3. We need persistent handles. That's like basics, right? That's a transparent failover, which, apologies, as usual, we have multiple names for the same thing, and we kind of use them without warning, right? And we abbreviate each one of them. But transparent failover, CA, and persistent handle are effectively the same thing, right? It is the ability to survive that failure of a node and move transparently to the other one. That is basic, right? And multi-channel for the multiple paths piece of it. Like that you have 2 NICs and then one dies and you continue to work. Because one of the things that, when you talk to the Hyper-V team, one of the first things they talked to us was saying, okay, but we can do this thing with Hyper-V over SMB, but you absolutely must not die when I pull one of the many NICs in the system. You have to survive that event. That's a basic thing, right? Multipathing is really something critical in a data center environment. So those 2 capabilities, I think you shouldn't really try to deploy Hyper-V over SMB without having those 2 in place. Or at least some guarantee that you can survive properly and persistent handlers. That's the way to go. And from a networking perspective, that you can survive the NIC going away. I've seen some folks saying, oh, I have other strategies for surviving the network going away. As long as you can, multi-channel is the best way to go about doing it. That whole thing with durability is not good enough, right? We have a lot of this conversation, oh, I can survive. Look, I can do it. But then certain things don't work. It works on a sunny day, but if you're renaming something, oh, I'm sorry, you didn't mention that it has to survive renames, right? So it has to be a complete solution. It's not just repeating reads and writes. There's more to it than it, right? And then after you're done with that, there's a whole set of things that I kind of bucketed as management, which are very good to have. I would argue that you should spend time on those immediately, which is the backup solution, right? Some storage that you can't back up, probably not a great idea. Then the witness piece for faster recovery that we described, so that you can fail fast without taking a timeout. The shared VHDX, which surprisingly, those are kind of like in the order that I was kind of trying to sort them in. Then SMB encryption, and then SMIS file. Jose, you're saying that SMIS file is not in the top tier? Well, because you can offer your own management interface, and someone might bite in and say, oh no, I'll use your management piece, but I really want to manage this with VMM. So you'll hear that as they start to deploy larger systems. So SMIS file is important. Then in the last bucket is the set of things like multi-channel for performance, right? So and SMB direct and rebalancing, and those things are excellent. Everyone will love when you implement those pieces because they will give you much more performance, they will behave better. But in general, if you don't have that last bucket, nobody will die, right? It will be all good. It's just kind of a differentiation thing going on there. And those 2 at the bottom, branch cache direct releasing, it really doesn't matter for the scenario we're talking about, which is the Hyper-V SQL scenarios, right? So those are not really that important. I'm not saying don't do those. I'm just saying don't do this for this reason. For the traditional workloads, that matters a lot. So that was it. We could probably spend, I have like 100 backup slides in this deck. and we'll probably share it. But the notion is this was kind of giving you a big overview and trying to put priorities in your head in terms of what is the most important pieces of it. Questions? Concerns? Yes? The man with the mic.
Just really quickly, the new op that was added to witness in 8.1, is that related to is that tied to the negotiation of 302? In other words, if I have an 8.1 client using 3.0 to talk to my storage and I'm running witness, what is sort of the expected behavior of the witness service itself, right?
I think the notion is if you're a 3.0 client talking to the new 3.02 server, you negotiate down to 3.0, you don't know how to do per share redirection.
Right, but in reverse. Is it tied to the asymmetric capability of the share? Is there a bit that determines whether the client...
No, the asymmetric piece is only relevant when you have the ability to do per share redirection, right? And that requires 3.02 on both sides.
Right, got it.
So the real change there is that in the old days, you would connect to a scale-out file server, you get one of the nodes, and that's it, right? You can kind of redirect to the multiple nodes, but there's no tie between the share name and where you land.
So you shouldn't expect to see the witness register EX op from a client unless you both negotiate 302.
I think that's accurate.
You need the share cap cluster flag indicates that you've got a witness server available on that SMB server. Share cap cluster is tied to the 302 dialect, so you shouldn't ever see share cap cluster. Well, no, you'd see it on.
No, there's asymmetric.
Yeah, asymmetric is different. Asymmetric is a property of each share, right? So witness is driven off share cap cluster, though.
Yeah.
So there are two levels here. I'm sorry. Maybe I don't completely understand the question.
Yeah, that's fine. I can follow up.
Yeah. But the behavior change there is basically to allow you to redirect differently for each share when that applies. Because you can actually have, that's a less understood thing, is that you can have a 302 server where the storage is evenly connected to all the nodes, and then you don't get the per share behavior by default. Right? It's only when you have asymmetric, when a node is better than others for doing these things, that we will enable this per share behavior, right? The typical case being the store spaces with mirrored disks that you have a preference for a node that manages that volume, right? Any other questions?
So one of the things that was kind of interesting as people were poking around was looking at Witness does other things other than what we're describing.
Mm-hmm.
Apparently network topology changes also trigger Witness, and I assume that would include things like popping an adapter and a server on the fly. Are there other things that Witness notifies about other than network topology changes and a server going down or a share moving?
Those seem to be it. Anything else that comes to mind? Tom?
The share moving is a property of 302 witness, right? That's the new the witness v2. I don't know what it is, but there are two versions of the witness protocol.
Yeah.
The original one, which could monitor net names and addresses, and the enhanced one that also monitors share names.
Yeah. So there's the original one here.
Yeah.
And then the new
There it
one.
is, witness per file share. So the questions you answered depend on the version of witness that the server implements.
Yeah.
Now discovering new network interfaces, that's actually an SMB function. The SMB FSCTL query network interface info, that's the multi-channel request.
But there's a witness.
There is a witness for interfaces as well, that's right. Addresses and net names, basically.
It tells you to go ask.
Well, yeah, it tells you you can reach the server at that address. It doesn't tell you to go ask. The go ask FSCTL query network interface info is kind of automatic. SMB does that on initial connection and then every 10 minutes.
So the witness network topology, whatever thing, the witness notification
Right.
asynchronously.
Right. Just says this address is moving to this node. You better go there to find it.
But it doesn't auto-trigger
implicitly it will, because when the server reconnects, it replays everything.
It does
and,
the whole dance again.
and it'll do it all again. But Witness doesn't explicitly drive the SMB3 protocol to do anything except go connect at another address, right? So for a migration, for load balancing, or for a move of a network name because of a cluster takeover event, those kinds of things.
But if you're looking
that's what
at-
Witness does.
But if you're looking at the client behavior, you're kind of on the right path. So something moved, then tells the client moves. When the client moves, then the multi-channel connections that existed don't exist anymore. You reestablish connection, and you do the multi-channel dance again. And you can kind of argue that it got triggered by the fact that the witness sent the signal, but those are independent. It's kind of an implementation.
Cause and effect, basically, yeah.
The reason I'm asking for your demo, right? You guys made the mistake of doing a demo. So, so one of the things you did in your demo was you put a network adapter in a server, right? You put a network adapter in a server, and performance doubled. You had one of those fancy Mellanox cards.
Yeah, but this is an effect of our client. So our client listens to interface arrivals, right? When that happens, it triggers us going and looking again. That has nothing to do with Witness. Yeah,
Okay,
that's
so
correct.
so this is kind of what puzzled me, because Spain loses a World
And that's
Cup
the
game.
reason why we
floods the
always, when
site.
we do those demos, we plug the network interface in the client. Because if you plug the interface on the server, it makes for a very boring demo where you have to wait 10 minutes for the client to discover, right? Yeah. I didn't cheat it. I carefully chose the scenario that best made my point.
It's a demo. So we will interrupt this for a brief commercial.
Wow, we have commercials.
Yeah. I'm S.W. Worth. I'm the co-chair of Storage Developer Conference, which most of you know comes up September. This year it's September 15th through 18th. Same place, Hyatt Hotel in Santa Clara, California. Co-located with the amazingly fabulous SNIA Plugfest for SMB and also for iSCSI.
And Bears 49ers.
And that's relevant.
Bears 49ers.
So unfortunately, there's an American football team in San Francisco, and for some reason they decided to play their new football games in the new stadium in Santa Clara, about a mile from the hotel. So those of you who are planning to go to the Plugfest, because the Plugfest starts on Sunday morning, will want to be moving out like as soon as you get out of this room and getting your hotel reservations for Sunday night there. Otherwise, you're going to be sleeping in the parking garage, and they'll probably charge you $50 to do that. So it's going to be a little unpleasant this year.
On the other hand, you can choose to stay in Sonoma and
there
commute.
you go. and try to commute. So, hands up. How many of you have never been to the SNIA Plugfest? Great. Okay, so the other people will smack you around during the intermission and explain to you why that's a big mistake. Basically, it's kind of like this, except you get to hang out with 400, 450 hardcore storage geeks for 4.5, 5 days. And we have a very long track on SMB, as well as file systems and solid state storage and cloud storage and NFS, et cetera. So not only should you come, but you ought to go back to your home companies and say, this is way much more cooler than staying here at work and doing boring stuff, because you will learn a lot. You get to see really great speakers. For those of you who submitted and have been bugging me about why you haven't heard yet, it's because we got something like 260 submissions this time for less than 92 breakout slots. But we already know that the main stage speakers are going to be people like Professor John Osterhout from Stanford, and let's see, Bob Brennan, who's the VP of Storage Engineering for Samsung. He spent many years at Intel. A couple other interesting people. So good main stage speakers, a lot of your fellow storage geeks as breakout talks. And of course, the Plugfest, where you can do Plugfesting on SMB from Sunday morning through Thursday, 24/7. So it'll be big fun.
Cool. So if there are no other questions, we're going to wrap up. Thank you.